Well, good morning and good afternoon, everyone. Thank you for taking the time to call in. My name is Christopher McGinty. I'm calling in from Logan, Utah, and I have the honor of serving as Executive Director for AmericaView. Again, thank you for taking the time to join us to learn about AmericaView, remote sensing and Earth observation education, the USGS and NASA Landsat program, and our collective vision of empowering Earth observation education across the United States and beyond. We have a great series of speakers for you today. We're really excited, truly exploring the important and broad impacts of Earth observation in so many different fields and different aspects and careers. And we certainly appreciate your time and the time that our speakers have taken to prepare the remarks for the briefing. AmericaView also thanks Congressman Joyce and Congresswoman McCollum for their remarks supporting AmericaView and the Landsat program. And we hope that you have a good opportunity to learn about Earth observation today. Certainly looking forward to questions and comments. And with that, I thank you again and turn the floor back to Dr. Brad Shellito as your host and moderator.
All right, thanks very much, Chris. Like Chris said, my name is Dr. Brad Shellito. I'm a professor at Youngstown State University. I am also a member of AdahOView and a board director of AmericaView, which is a national STEM education nonprofit, which is why we're all here to talk about this today. Thanks again for joining us here this afternoon, and I will be the moderator for our whole session. Now, this whole program of a national program called AmericaView actually all began in Ohio. In 1997, it was the brainchild of a group of professors within Ohio to have education and outreach and STEM workforce engagement and access to satellite imagery. And what began in Ohio grew out to an entire national program here today. So what you're going to be hearing about is going to be, you'll be hearing things from members of Congress, you'll be hearing things from professors, from experts in the field, from students, all about the importance of remote sensing, about satellite imagery, and about how STEM education works. We all use this stuff on a regular basis, and what we'll be talking about here today is the importance that it all plays within our daily lives. Now, as we go on, if you have questions, we'll ask you to please post those questions in the chat. And we'll be having a Q&A at the end of our particular program here. And also, if your question is meant for one of our particular speakers, please put that in the chat as well, so we can make sure that we pitch those questions to the most appropriate person possible. Now, we are recording this meeting, and after we're done, we'll send you a link over to this particular briefing. So you'll have all this information available to you. Now, like Chris mentioned, we do have 5 speakers for you today, but before we get on to our main speakers, what we'd like to do is start with some remarks from 2 of our congressional champions, David Joyce, who represents Ohio's 14th Congressional District, and Betty McCollum, who represents Minnesota's 4th Congressional District. Now, the first person we're going to hear from is Congressman Dave Joyce. And Congressman Joyce is the chair of the House Homeland Security Appropriations Subcommittee, and he's the former ranking member of the Interior and Environment Appropriations Subcommittee, which funds the USGS. His district spans across Northeast Ohio. It borders Lake Erie in the north and Pennsylvania over in the east. During the first session of the 117th Congress, Congressman Joyce was once again recognized as one of the most effective and bipartisan lawmakers in Washington by the Lugar Center and Georgetown University's McCourt School of Public Policy. So without further ado, I am pleased to present Congressman Dave Joyce.
Hi, Congressman Dave Joyce here. As the former ranking member of the Interior Appropriations Subcommittee, I understand the important role USGS and NASA-enabled Earth observation and satellite imagery play in our daily lives. I worked hard with my colleagues on the subcommittee last year, including Congressman Betty McCollum, who you'll also hear from today, to provide additional support for this work through the Remote Sensing State Grants Program. This satellite data impacts decision-making on issues spanning from security to health to transportation. And with the explosion of technologies using this information and the growing workforce demand in this field, I'm proud of the work AmericaView, AdahOView, and the dozens of other state views do to train students pursuing these careers of tomorrow. During this briefing, you will hear from AmericaView Board Director and fellow Buckeye Brad Shellito and other experts about some of the education and outreach initiatives they are working on to benefit our local communities and our country. AdahOView, initiated in 1997 and the first state view, was truly a pioneer in this field and led to the national consortium we have today. They have been doing important water quality monitoring and education work in the state. And as I say to my colleagues, water is the new gold, and we are blessed with our water resources in Ohio. So I will continue to do my part to partner with OhioView and others to protect this precious natural resource. Thank you again for the important work you do and for hosting this educational briefing. Have a great day, and God bless.
All right, and next we will hear from another leader in Congress who hails from St. Paul, Minnesota. In 2000, Congresswoman Betty McCollum made history as only the second Minnesota woman elected to serve in Congress since statehood in 1858. Congresswoman McCollum brings a common sense Minnesota perspective to her work as a senior member of the House Appropriations Committee. And she also serves as the top Democrat on the Defense Subcommittee and is the former chair of the Interior and Environment Subcommittee, where she worked tirelessly to increase investments in both the Department of Interior and in the USGS. So Congresswoman McCollum, please.
I'm Congresswoman Betty McCollum, and I represent the families of Minnesota's 4th Congressional District in the U.S. House of Representatives. Welcome to today's discussion on AmericaView, an amazing public-private partnership between the U.S. Geological Survey, NASA, including university and state-based collaboratives. These networks of scientists, educators, and technicians help us to better understand and visualize our world. I'm a former chair and current member of the Interior Environment Appropriations Subcommittee, which funds the USGS, including programs providing remote sensing data used by AmericaView. AmericaView uses satellite data that the federal government has in its open archives to provide the opportunity for everyone, from school children to research scientists, resource managers, to see and study our changing world. If you've ever seen the blue marble photos of our Earth from space, you know the awe-inspiring beauty and complexity of our federal satellite imaging programs. AmericaView will help us all benefit from that inspiration. By using remote sensing data, we can ensure smart, informed decision-making happening for our future. It can enable us to learn about our natural environment, including helping forest managers to observe wildfire recovery. It can help farmers to visualize the health of their crops and even monitor their water use over time. And STEAM students, and we say STEAM in Minnesota, not STEM, because Earth observation is an art as well as a science. Well, it helps us to develop new ways to understand our world better. We're especially lucky to have Dr. Knight presenting today, who heads the MinnesotaView program and the Remote Sensing Geospatial Analysis Lab at the University of Minnesota, along with many other researchers. Enjoy your exploration today, and thank you for your hard work.
All right, thanks very much for those remarks from both Representatives Joyce and McCollum. Here at AmericaView, we greatly appreciate all of the work that you are doing in Congress to work with the members here of AmericaView to make effective use of the 51 plus years of data captured through the Landsat mission, as well as any other key satellite data for the betterment of society. But y'all didn't come here to hear from me. You came here to hear from our 5 speakers for today. Our 5 speakers, like I said, are all going to be coming from different fields that are utilizing remote sensing and satellite imagery, and basically utilizing that kind of technology for development, for outreach, education, workforce development, and engaging students in STEM applications that's going to lay the groundwork for very strong and meaningful careers here with this kind of space-based research. We have our 5 speakers here, and the first one I was going to introduce you to is Lisa Wirth. Now, Lisa is the program director for AmericaView, and what she's going to do is introduce you to what this AmericaView thing is that we were talking about here, what the Landsat program is, and show how they're both used in empowering Earth observation education across the nation. So I'll turn it over to you, Lisa.
Thank you for the great introduction, Brad. And I also would like to thank Congressman Joyce and Congresswoman McCollum for their remarks on behalf of AmericaView. And then, of course, welcome everyone on the call today. Thank you so much for taking time out of your day to be with us and learn about AmericaView. So as Brad mentioned, AmericaView is a nationwide STEM education nonprofit, and we focus on Earth observation education through remote sensing technologies. And there's a number of ways that we accomplish this. The first is through education and outreach. Some of our efforts have been to host STEM events or STEAM events for underserved communities. Most recently, AmericaView has been working with the Navajo Nation, bringing STEM education opportunities to a Bureau of Indian Education school outside of Gallup, New Mexico, and to the Window Rock, Arizona community. And these have been fabulous opportunities to work with these two communities. AmericaView members also develop material and training opportunities throughout the year to help the current workforce remain knowledgeable and trained in emerging technologies and resources. You'll hear some of that from Joe in a little bit, and that's one of the things that Brad does out of Ohio. Many of our members conduct applied research, educating and training undergraduate and graduate students, thereby preparing the future workforce to solve real-world problems. And then technology transfer is really central to all of what we do. We teach learners of all ages about geospatial technology, how to use it, and how it can benefit their lives. Next slide. And so as Brad mentioned, AmericaView began in Ohio in the late 90s, and that initiative showed incredible societal benefit that it led to the creation of AmericaView as a nonprofit in 2003. And then we have since grown to 41 states, and we have 2 levels of membership, full and associate, and it is our goal to eventually be, have members in all 50 states and Washington, D.C. And so each of those states have a state view director that is housed within a university, and they run their program that's funded by AmericaView through their university. And so this allows our program to really understand and meet the needs of each state, because those directors are in the communities and they understand how to best address the needs of their state. And so through this design, AmericaView is able to take those federal dollars and really get them into the local communities where they can be of the most benefit. Next slide. And so we've been talking about remote sensing and Earth observation. And so before we get into it in any more detail, I want to briefly explain what those means and how it relates to AmericaView's work. So remote sensing is simply observing an object from a distance and collecting some type of information on that object. And so this can be accomplished through many different things, such as a drone, an airplane, kite, balloon, and a satellite. And so much of our work uses data from the Landsat satellite missions. And so an example of using this information is shown here on the right. This is satellite imagery that allows the monitoring of the development of surface mining in eastern Idaho through time. And so if you'll just notice, the time series begins in 1984 and continues through 2022, just allowing someone to monitor what's happening on the surface of the Earth through time. Next slide. And so Earth observation is simply taking the information that is collected from a remote sensing platform and doing something with it. And so there's many applications that AmericaView members focus on that help create solutions within their state. For example, some states have assisted their local city governments with urban forest mapping to help them better manage those resources. Many states work with farmers, ranchers, and the commercial agriculture industry to help them better manage their rangelands and crops. And there's many more that I don't have time to cover today, but all of these projects are educational in nature by involving undergraduate and graduate students. And so incorporating Earth observation education into academia gives students the opportunity to become problem solvers for issues that are affecting their local communities, allowing them to have a positive societal impact that will lead to an innovative career as they learn to use all of these tools that are available in Earth observation and remote sensing. Next slide. So the Landsat program is central to everything we do at AmericaView. It is a 51-year partnership between NASA and USGS and is the longest running satellite record of the Earth's surface. And so NASA builds and launches the satellites, and once it's safely in orbit, it is turned over to the USGS for the data downlink, processing, and distribution. And an important aspect to the Landsat data archive is that it has been free since 2008. Which has dramatically benefited the science and technology sector of the United States, which I'll cover a little bit more in more detail in a few minutes. And AmericaView fits into the Landsat program through a competitive grant that is awarded through the USGS, which is called the Remote Sensing State Grants Program. And so this grant is ran through the National Land Imaging Program of the USGS, and it's because of their recognition of the importance of remote sensing and Earth observation education that AmericaView is able to take that federal investment of the Landsat program and make those tax dollars meaningful and useful within the states. Next slide. And so while Landsat is important in almost every sector of our society, I would like to focus on two topics over the next several slides. The first being that Landsat is essential for education and growing the tech workforce. The free and open Landsat data archive provides many educational opportunities that just would not be possible without it. For example, our member in Wyoming has undergraduate students work with Landsat data to conduct research projects every year. And so many of these students have family farms and ranches in Wyoming, and there are numerous success stories where they use the data to help their relatives improve their land and livestock management practices. And so this image on the lower left is one of those students who developed a video showcasing his research and how it helped his family ranch. And so many of these students have been able to take the skills that they learned and are able to get jobs in the state and federal government. And so second, Landsat is essential for many disaster response and recovery efforts. AmericaView has several member states, Louisiana, Mississippi, Vermont, and Wyoming, just to name a few, that are involved in disaster response and recovery. And this covers hurricanes, fires, and flooding. And so this image in the middle is an example of our responders mapping and monitoring floodwaters on the Mississippi River. And our Louisiana member conducts an annual geospatial disaster first responder training as part of their program to ensure that responders are up to date in the latest technology, methods, and procedures. Next slide. So as I said earlier, prior to 2008, or in 2008, Landsat data became freely available. But prior to this, it was not freely available. And if you wanted to use the data, you had to purchase it per scene. And so this severely limited the use of the data because most researchers just simply couldn't afford to use it. And this graph illustrates the tremendous impact on education of the free and open data policy that was enacted in 2008. The blue line on this is showing the cost of one single scene through time. And the orange line shows the number of citations in peer-reviewed publications that resulted from using Landsat data in their research through time. And so the use of Landsat data and the number of Landsat citations grew exponentially after 2008 when the data became freely available. And so I began my graduate program at the University of Alaska Fairbanks in 2008. And at the time, I didn't understand why my professor was so excited to encourage me to use Landsat in my research because I thought it had always been free. And it wasn't until a few years later when I began trying to work with data from other commercial satellites that were not free that I realized how lucky I was to have been a student after that free and open data policy. Because having access to Landsat data allowed me to conduct meaningful research that just wouldn't have been possible without it. And it had a positive impact on inland fisheries management for the Alaska Department of Fish and Game. Next slide. And so Landsat is also essential for disaster response, monitoring, and recovery efforts. Shown here is two Landsat images of the Funny River fire in Alaska that occurred in 2014. And so Landsat is a sophisticated scientific instrument. It doesn't just take pretty pictures. And because of the sensors on board, responders are able to take the data and filter it for their specific purpose. And so in this example, the image on the left is, how your eyes would view the wildfires. So what we call a natural color or true color image. And the image on the right uses a different combination of the information that allows most of the smoke to be filtered out. And so this enables emergency personnel to be able to view the fire perimeter, the burn severity, proximity to any structures. It allows them to see which direction the fire is moving, which all of this allows them to better protect life and property. Next slide. And so Landsat has proven to be essential for so many sectors of our society. And the 51-year data record allows for us to be more knowledgeable and better prepared to deal with the variety of issues we face today. The continuation of the Landsat program is essential for us to be prepared for the issues that we will face in the future. And so Landsat Next is the continuation of the current Landsat program that's scheduled to launch in the late 2030 timeframe. And Landsat Next will build upon the successes of all of the previous missions and improve the future of remote sensing and Earth observation. And so we have a very short video to show you that will describe the Landsat Next mission in more detail.
All right. Thanks very much, Lisa. One thing, as Lisa pointed out, Landsat satellites have been up in the sky since 1972. And it's like how a colleague of mine says that Landsat is the world's only legitimate time machine, that we have a 51-year archive of every spot on the Earth's surface that we can take a look at and see what's going to be happening and changing on any of these locations around the world over this 51-year time span. But our next speaker is going to be talking to you about basically her journey here as a PhD student, working hands-on with all of this information. It's my pleasure to introduce you to Anushree Badola. She's in the Department of Geosciences and, again, a PhD student at the University of Alaska Fairbanks. And take it away, Anushree.
Thanks, Brad. Hi, I'm Anushree, and my research focuses on mapping vegetation in Alaska using various remote sensing data. So today, I want to walk you through my PhD journey, where AmericaView has played a significant role in providing me with a wonderful research, outreach, and networking experience. I will begin with my research work. The work, next slide. Yes, I'll begin with my research work. The work presented in both the papers shown here have been partially supported by AmericaView, and these papers are the second and third chapter of my PhD thesis. For the paper on the left side, we came up with a novel approach to generate vegetation maps for the whole Alaska and shared the map product and method with the fire managers. This paper was published last year, and the map product and algorithms are made publicly available so that more people can use them. The paper on the right side presents work on mapping conifer vegetation in Alaska, since conifer are highly flammable species, so mapping them is crucial for fire management. This paper has already been submitted. During this research work, I even got an opportunity to work at NASA JPL. It was a great learning experience for me. Next slide, please. So I believe PhD is not just about research. It is about sharing our knowledge with the community as well. I got a huge opportunity to work with edX, an online course platform. And with the help of our university's eCampus, we created 4 online courses that involve content creation, designing, and instruction. These courses became very popular, and the total enrollment reached more than 24,000 with the students from all over the world. It feels great to receive student feedback through my LinkedIn account and through emails. During the whole process, I realized that teaching is something I really want to pursue next. So that was all about my teaching outreach experience. Next slide, please. Now I want to talk about another very important part of a PhD life, that is networking. AmericaView provided me the opportunity to attend the 2022 Picora conference in Denver. That is a renowned remote sensing conference, and I can say that that was the best conference experience I had so far. I presented a case study of a big fire event that happened in 1983 in Alaska, and I will be presenting an extension of the same work at the upcoming IEEE IGARS conference in Pasadena. So during the Picora conference, I met many people whose papers and books I had read before. It was a great and memorable experience for me to meet them in person and hear about their experiences and learn from them. I also made many new friends during the conference. Additionally, I got the opportunity to participate in an outreach activity conducted by AmericaView during the conference, which was great. Next slide, please. Another outreach program that I was a part of was STEAM Night at Pearl Creek Elementary School here in Fairbanks. During the event, I interacted with kids and showed them images from different timestamps. They got super excited to see the changes over time, and I was amazed to see their interest. It was another great experience, and I had so much fun with the kids. So to wrap up, my PhD journey has been filled with wonderful experiences, and being a part of AmericaView Group has contributed immensely to this journey. Thank you.
All right, thank you, Anushree. I've seen that a couple of questions are starting to come into the chat. We're going to have time to get your questions answered for you at the very end, so please keep posting them and we'll make sure that we have time to get everybody's questions addressed at one time. But our third speaker I was going to introduce you to here is Dr. Donna Delparte from IdahoView. She's a professor in the Department of Geosciences at Idaho State University. And what she's going to do is show you how AmericaView is training the next generation of students in cutting-edge remote sensing technology in relation to mapping landslide potential along transportation corridors, as well as monitoring thermal conditions in streams. That's going to be looking at spawning areas for salmon and red band trout. So take it away, Donna.
Thank you very much, Brad. I'll start with showcasing some of the applied research projects that we've been doing here in IdahoView. And we undertake these different projects for the benefit of the state of Idaho. And we work with partners from across the state and across different agencies. An example here is kind of a timely thing about train derailments. And in this case, train derailments that are caused by landslide activity. So we've been working with Idaho Geologic Survey to kind of identify those slopes. For example, on the left, where railway cars, grain cars, were derailed by a landslide that undermined the railway track at the top. And on the right-hand side, where rockfall caused a rail car derailment into the Kootenai River in northern Idaho. Next slide, please. So we've been using advanced remote sensing techniques using something called LiDAR that gives us a really good picture of the ground surface of these areas. And we've been doing repeat surveys over time, looking kind of what's going on with the slopes, how they have changed over time, and monitoring those slopes and helping kind of forecast where the next slide or susceptibility of different slides may impact railway corridors. And here on the right, you can see above railway cars here carrying hazardous material. just below, just outside of the picture, is right above the river system. So these do pose threats to our environment, and we want to work with our partners in identifying those slopes that may be susceptible to this kind of movement. On the left-hand side is a student that's learning this cutting-edge technology, and she was hired before she was even finished her degree program. These skills are in such demand. Next slide, please. And what we can do with this remote sensing technology is essentially strip away the vegetation. So on the top, you can see two examples here where those train derailments happened, and we can kind of strip away the vegetation and start examining what's underneath and looking for those slopes that have that susceptibility for movement and being able to do change detection. So how much material is moving and when maybe that movement happened. Next slide, please. And here's an example of it. So looking at those 2 years of change, in this particular slide, the blue represents area of where there was slide movement, and below in the red is where we saw that material be deposited. Next slide, please. As we kind of zoom in here, we can start kind of doing measurements. So looking at that area of blue, we can see that loss and start to measure where there's significant change. We can also look at the imagery to see what the result is. And here we have about 7 dump trucks worth of material that was sloughed off the slope and then deposited below. Next slide, please. Moving on to another project that we've been working in conjunction with Shoshone-Bannock tribes. Here we're looking at Chinook spawning and looking at these nest sites that the fish build. So on the right-hand side here, where the red dot is, you can kind of see a slight depression area. And that would be where a salmon has scooped out material in the riverbed and laid their eggs, and the salmon will spawn in that particular nest site. You can see on the left-hand side, kind of a density, red is higher, where we see more of these nest sites as part of where the fish are spawning. And we have students here that are using an array of sensors and learning how to use those and capture this really amazing imagery. Next slide, please. A couple examples here. So as we fly the drone and collect this data, we can use these remote sensing techniques to identify in the stream bed, these yellow dots here on the right, where we would see spawning salmon nests, and then look at the imagery on the right. And now we can start doing some modeling. Next slide, please. And what we're interested in is the depth. So what is the water depth near these spawning salmon sites? Next slide, please. So using remote sensing techniques, we can check the depth. We can look at the stream gradient. How steep is the slope? Is it a pool, a riffle, or an eddy, for those of you who may be fishermen? Next slide. We can look at stream velocity. What kind of stream flow is required for these nesting sites? How are the salmon choosing what type of stream velocity is necessary for these nests? Next slide. And then we can look at temperature. So across the stream, we can look at high and low temperatures and look at what are the temperature regimes that spawning salmon require. And this is where it can get interesting, because now that we have this data, we can start turning the dials and forecasting what a certain spawning return year might look like. Next slide. Another one of our projects is looking at precision agriculture. So of course, coming from Idaho, we have potatoes, and we've been working with our local growers to identify something called potato virus Y. And potato virus Y is a worldwide virus that impacts potato plants. And sometimes in potato plants, it's very hard to detect. So in the center slide there, you can kind of slightly see the plant that's lower down, a little bit smaller, maybe a little bit of a wrinkly material in the leaf. That would be a sick plant. but very, very hard to detect and isolate. So we've been using these advanced remote sensing techniques to detect these individual plants in the field that can help growers identify them and remove them early. So here on the right-hand side, we have a student that is out learning how to use GPS equipment. And we take that GPS dot and we're able to put it onto an image. Next slide, please. So once we kind of gather in that data from our potato plants, we can start looking at this very detailed information, what we call spectral signatures. It's like a fingerprint for a plant. So each plant has a characteristic fingerprint, and a healthy plant has a different fingerprint than a plant that is sick. So using that information, we can tease that out and help growers identify this real problem that impacts yield quite significantly in our Idaho crops. Next slide, please. Our next steps, we're really excited this year to try deploying this real time. So we have field trials coming up in 2023, and we're going to be going out to the field site, flying this data, collecting this information, and then providing it to the growers. So we think this is going to have a really good kind of future management approach for growers to manage this crop threat. Next slide, please. Another part of this precision agriculture is nutrient management. So part of the picture of crop management is managing your nutrients. So on the right-hand side, you can see kind of Landsat imagery. So we're using Landsat imagery in these pivots. And so this pivot at the bottom here shows a crop site. It's got this sort of variable terrain. And you can see how red and dark green represent productivity level across that field. So we can help farmers identify how to variably provide nutrients across the field, applying more nutrients where the crop or what part of the crop needs it most, and then less where it is not as much a requirement. So we can help with this variable rate application of nutrients and actually provide a grower with a thumb drive to plug in the tractor, and they can go off and fertilize based on this variable rate formula. So this is something that growers have been really excited about. It's cost efficient and helps them with their return on investment. And this is you really leveraging our Landsat data and looking at the health of our crops over time. Next slide. I think that's it for me. Thank you very much, everyone.
All right, thank you, Donna. One thing Donna mentioned is that like all of these things, precision agriculture, nutrient management, flying drones are all skill sets that are in demand for applications in today's workforce by students. And to kind of speak to that is going to be Mel Campbell here, who is a Master of Science student in the Geographic Information Science program at Idaho State University. And they will share the work that they are doing with trout habitat in the Owyhee Desert of Southwest Idaho.
Thank you. Thanks for having me. Again, my name is Mel, and I am doing some work with Dr. Donna Delparte, and I'm very excited to tell you about it. We are using drone imagery to help model stream temperatures in Little Jacks Creek. Next slide, please. So Little Jacks Creek is an intermittent desert stream in southwestern Idaho, so it's very hot, especially in the summer, and it does not flow constantly throughout the year. But it's very unique, as well as other desert streams in this area, because they contain thermal refuges, and these are places where cold water fish hide to regulate their body temperature when the general stream temperatures get too extreme for them to handle. And we can actually map out where these refuges are located throughout the stream using remotely sensed imagery from our drone, and that contains temperature data. And we can also gather this data over time to try to model and predict the variations in the refuge locations over time. Next slide, please. So we did this for Little Jacks Creek by flying 1 aerial survey per hour for 24 straight hours. And it was a very, very amazing but tiring experience. And it was really neat because it was my first time out at this site, and I had been working on some other imagery from here for the past few months for Dr. Delparte. And so it was really cool to come see it in person. This is our little setup here. We had a few sleeping bags set up in the cars or on the ground, and coolers with lots of food and tons of clothing because of the wide temperature variations out in the desert. And while we were out there, we also brought some other geosciences students with us to help learn how to set up and operate these drone flights. So they got to have some hands-on experience with that. Next slide, please. So we used this drone. It's a DJI Matrice, and it has a MicaSense Altum sensor, which allows us to look at multispectral and thermal bands. And so the multispectral bands will give us information about mainly vegetation, and then the thermal bands will give us the surface temperatures of the stream and the surrounding environment. So we flew this drone once every hour from around 1:30 p.m. on September 11th to noon on September 12th. And it used a ton of batteries. So I had to take a picture of our light show we had at night. And it was, like I said, very tiring, but it was a beautiful experience. As you can see in this picture on the left, the sunsets and sunrises out there were amazing. And we actually got some really good data out there. Next slide, please. So this is just a couple of small examples of our data products. The one on the left is the natural color, or RGB, if you want to simplify it even further. And this RGB, these orthomosaics is what we call them, and they are essentially very large 3D images that let us really visualize the study area without having to be there. And so this RGB, or visible one, lets us see the study site and see how the temperatures in the stream vary, as you can see in the thermal cutout of the stream here. And we also checked our thermal temperatures from the drone sensor against the actual stream temperatures, because we had temperature sensors in the stream as well. And our values came very close to the actual temperatures. So that was very exciting for us to see. And this RGB and the other multispectral orthos can be used for vegetation analysis. As you can see in the middle section, we can use that information to classify where the vegetation is, where the shrubs are, where the water is, just using that imagery. And then on the right, you can see another orthomosaic. This is called a digital elevation model. And this allows us to do a ton of different things. We can calculate the stream flow as shown in this image on the right. And we can also calculate the incoming radiation from the sun on the surface. We can estimate vegetation canopy height and volume. We can estimate stream velocity and discharge, as Dr. Delparte showed in her earlier slides. And so we can combine all of this environmental information to determine how the cold water refuges are distributed in the stream with respect to the vegetation and elevation and the radiation from the sun and so on. And then we can use that to predict where the refuges are as those factors change. And this will help us find where more persistent refuges are and help us conserve the existing refuges. And that will help us conserve our native red band trout populations. Next slide, please. And this is just a short video of our matrice taking off into the sky. This was probably around 8 o'clock at night. And that's all I have for you. Thank you.
All right, thanks very much, Mel. Last but not least is going to be Dr. Joe Knight, who is a professor at the University of Minnesota and is also a board member here from AmericaView. Joe's going to be batting cleanup here for our remote sensing starting lineup and talking about the remote sensing work that he is doing there in Minnesota.
Great, thanks, Brad, and hello, everybody. I'll be brief so we have time for questions. AmericaView, collaboration with AmericaView has been really important for a number of things that we've done in Minnesota in the remote sensing research, teaching, and outreach sort of areas. I'll just highlight a few things briefly here today. If you'd like to see the status of Minnesota lakes over multiple decades, you can go to this URL there at the first bullet, lakes.rs.umn.edu. Points if you can figure out what RS stands for, right? So we, over a number of years, we have assessed all lakes larger than 10 acres in the state. You may know that Minnesota is the land of 10,000 lakes. Well, they're actually more than 12,000, and a large percentage of those are larger than 10 acres. So we're talking about the vast majority of lakes in the state here. And they're assessed for a number of different water quality parameters, including clarity, which is the one that you see depicted here in the figure. So you can click on a lake in this what we call the lake browser, and it pulls up information about the status of the lake over time. Really interesting and a great tool for public engagement and teaching, and also, of course, research. So the tool provides a number of different measurements: chlorophyll, color dissolved organic matter, if we want to get technical about things, but basically information about the health of the lake over time. A really important tool. And it's recently been expanded to provide multiple snapshots of lakes over the course of a year. Next slide, please. More recent thing that we've been doing, and this also has been done in collaboration with AmericaView, is looking at the spread of the invasive reed Phragmites australis. So this thing originally came from Europe, and it grows it's invasive in Minnesota and much of the upper Midwest, grows in really dense stands, chokes out all native vegetation, and it spreads through a number of different mechanisms, really causes a lot of problems. And we're trying to fight against this invasive species in Minnesota right now. So we're using remotely sensed methods to do that. The figure that you're looking at is the result of drone-based mapping. So using imagery collected by drones along with structural information about the surface, we're able to identify with quite high accuracy where Phragmites is. The green on that left pane of the figure is where we got things right, and the little bit of red is the incorrect. So that these techniques work really well. We're currently in the process of mapping forests statewide. So we did this back in the 2010 era, and we're doing it again now. To identify changes in the distribution of forests due to things like disease and pests and tree removals for timber production, et cetera. That's also all done with imagery and LiDAR, as Donna mentioned, so laser scanning of the surface of the earth. It's really cool. And we're focusing in particular on urban and community forests. There are lots of equity considerations, as you might imagine, in terms of access to green space, distribution of forests. And so an important component of this new project is looking at how distribution of green space correlates with socioeconomic data. Next and last slide. We also do lots and lots of workshops for stakeholders in Minnesota. So we have a number of different topics. I think there are six or seven different topics right now that we provide workshops for Minnesota stakeholders. These are people from state agencies, other universities, companies sometimes, right? So it's quite a large group, hundreds of people over time. And we've provided these workshops with the collaboration and support of AmericaView. And it obviously fits really well with the education mission of AmericaView. So great, that's all I have. And I think we're gonna take questions now. Thanks, everybody.
All right, thanks very much, Joe. Like Joe mentioned, we've had a few minutes left here at the end for questions, but we really hope that all of these presentations have given you a better understanding about what remote sensing really is. It's more than just taking a look at your house from space, though it can do that too. But all of these things, fighting invasive species, looking at environmental impacts, nutrient management, looking at the impacts of train derailments, looking at precision agriculture, are all going to be applications that are applicable across all 50 states here. Anyway, we do have a couple of questions that have come in. We want to grab them first. So our first question was from Alexander Smith asking, are there efforts to move even more regionally with directorships in larger states such as California? I'll pitch this over to Chris McGinty, our executive director, who can speak about that real quick.
Sure, thanks, Brad. Alexander, that's a great question. One of the things that we didn't really get into in depth is the structure of the AmericaView State View members, and each one of the state views actually has an in-state network or consortium that they build, and so it looks across the state to help identify some of those more, especially in the larger states where there might be other aspects or projects or opportunities to collaborate across a larger area. So California View is a good example. It's a large state. UC Davis is the host for California View, but they also have several dozen members to their network across the state. So if that doesn't answer your question, do let us know, please.
Yeah, and any questions you may have for any of our presenters, or just more in general questions about AmericaView, remote sensing, the Landsat program, please put them in the chat and we will take care of them here. Our second question is from Tammy Wall to say, is there potential for abuse of the program or the data that is viewed or collected? So Chris, if you wanted to start with that one, and maybe if Donna or Joe might want to jump in with that as well.
Sure. It's actually a really good question, Tammy, and certainly with any satellite or remotely sensed data, there's always potential for some misuse somewhere, right? And this is something that we know. However, when you talk about Landsat data, it's what we would call kind of a medium resolution sensor. It sits somewhere between a high resolution sensor from a commercial vendor, that would look at maybe 1 meter or less, even down to inches. Or something like a weather satellite that's geosynchronous and quite a bit coarser. And so this moderate medium resolution data actually sits at a really unique nexus where you can't necessarily see all the detail on the ground, but the pixels have depth to them. So we look at different parts of the electromagnetic spectrum, and so we can identify different things that are happening, like Joe said, with forestry, or like Donna was talking about with nutrient management. Some of these things are certainly, we can winnow out of the data. But Landsat data, all in all, it's global. It's available to the global audience. Anybody can pick up a scene and look at it, use it for analysis. But there's not a whole lot of chance of it being used by a bad actor for something that you couldn't get from something like Google Earth or some other type of sensor.
Yeah, like Chris mentioned, the goal of Landsat is to be doing large-scale environmental-based analysis. And you've seen a lot in movies and TV shows where the satellite, can zoom in and read the bad guy's watch. That's a lot of science fiction, but it's also not going to be what you can do with Landsat. That's going to be used for looking at more large-scale types of environmental-based effects. Are there any other questions? Please put them into the chat. We'll be glad to answer them, whether it's got to do about any of the things that any of our 5 presenters were talking about, things related to the AmericaView program, or things related to the Landsat program as well. I know at one point I threatened to sing if there were no questions, so believe me, you don't want that. So keep the questions coming.
Thank you. While we wait just a minute to see if any other questions come in, just kind of reinforcing the importance of the collaboration between USGS and NASA with respect to the Landsat mission. 51 years is a really long time to have this incredible program running, and we're excited that Landsat Next will take that next step in continuing the data continuity and the ability to look at the Earth from this really unique perspective and continue to monitor what's going on the surface of our planet. And I think, one of the things that, we would welcome anybody to do is certainly go out to the USGS and NASA websites and take a look at what it is, what is the Landsat program, and dive into that a little bit deeper. You'll find that in your states, within your districts, that there are very many uses of Landsat, even if they're unseen. So take a look at that and keep an eye on that program as it continues to evolve through time.
All right. We have another question from Eric Morris from Congressman Simpson's office, who's the chair of the Interior. It was a question for Donna. Donna, have there been trials yet of using topographic data on a plug-in thumb drive, like you mentioned, to apply fertilizer at variable rates?
Yes, thank you for that question. And yes, my student and I have a PhD student working on this project, and he is very savvy with putting that satellite imaging data, boiling it down to kind of a fertilizer prescription, and then providing that on a thumb drive to those growers to apply their fertilizer. So yes, we've started some of that in collaboration with our growing partners.
Great, thank you. There's another question, again, from Alexander Smith. Is there anything that appropriators can do to assist the attainment of Landsat Next or assist the expansion or sustainment of the program? And I think, Chris, that's probably a question I can pitch over to you.
I think it's a good question, and certainly some of our USGS colleagues are online today, and we can gather more information from them. But the recognition of the importance of Landsat within the U.S. economy and the global economy is pretty important, and I think that needs to be realized, by our appropriations staffers and congressional members, and making sure that the importance of the continuity and the continuation of the program is there, and that we understand that this fits a really unique niche in satellite remote sensing. So it's not stepping in necessarily where a commercial entity would be, and it's not a weather satellite. In fact, many of the commercial entities use Landsat to help calibrate their data from their finer resolution sensors. So, the realization and understanding of the importance of the program, certainly the understanding of the importance of transferring this information, through education outreach and technology transfer and workforce development via the remote sensing state grants program is key, since we were able to help USGS with that outreach component and really ingraining the use of this technology within the future workforce, within our future scientific leaders, within folks who are going to go back out on the land, like the Wyoming example of the students going back home to their ranches, taking this data and information and really making it applicable at the local level. So, there are a lot of things there, but realizing that the continuity of both the Landsat program and certainly the competitive grant that funds this work is something that we would like to put into your minds.
Well, thanks very much. I see by the clock on the wall that we are out of time. I really appreciate all of you coming here today. And again, we hope that we have managed to open the doors for looking at what remote sensing is going to be able to do in each of your states and all of its myriad applications, as we're working to go and train the next generation of innovators and thinkers and problem solvers here for the 21st century. Again, the link to the recording of this session will be sent to you for be able to review, and please feel free to reach out to us if you have any questions. Again, my name is Dr. Brad Shellito, and we are AmericaView. Thanks very much for coming, and have a great afternoon.